Sir, good afternoon to everyone, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon to everyone, sir. Krishna, sir. आप मेरा सुन रहे सर? Can you hear me, sir?
Yes, sir. Yes, sir. You are clearly audible.
Okay, sir. My colleague, Mr. N. Arun Kumar, is going to start the presentation, sir. वो अभी चालू करने वाला है. Arun, can we start, ma?
Yeah. Very long. Yeah, good afternoon, all.
Continue,
Hello,
sir.
good afternoon, sir.
Okay, sir. Good
Are you
afternoon.
able to see the screen?
Yes, sir. The
Are
screen
you
is
able to see the screen of my laptop? Yeah.
कृष्णा सर, लैपटॉप का स्क्रीन क्लियर विजिबल हो रहा है सर आपको?
विजिबल हो रहा है.
ओके सर. सर हम स्टार्ट करेंगे?
Yes.
अरुण स्टार्ट பண்ணுமா?
Good afternoon to all. I am Arun Kumar from Knorr Bremse India Private Limited. Today we are going to talk about the topic of electro-pneumatic brake system and air supply of Trainset coaches. First, I am going to give the introduction about my company. Founded in 1993, it is 100% subsidiary of Knorr Bremse Germany. The ISO certified and IRIMEE certified. We have the good infrastructure facility to machining and assembly and surface treatment of various testing facilities. KB India is having a design center to our product. Also, fully air-conditioned dust-proof shop floor facilities available in our factory. We have pan-India support for service, south, east, and west and north. Now, what are the products we are supplying to railway groups? I am just going to explain four categories of products we are supplying to railways. One is the brake control. It consists of panels in the locomotive, brake models in the railway rolling stock coaches, as well as some sensor control unit. In the bogies, brake caliper, brake disc, tread brake unit. In air supply, we are supplying compressor and air dryer. Similarly, hydraulics, shock absorbers we are supplying for railway application. The onboard we are supplying door system, air conditioning system, and windscreen wiper. Off train we are supplying platform screen door, signaling equipment, passenger information system, train safety and signaling equipment, driver training simulator. Now our agenda is today we are going to explain what is available in the train set coaches. The first heading is air supply equipment. Air supply we are considering as a piston compressor and air dryer, auxiliary air supply system for pantograph. The next is a brake control system. The brake control system controlling the three important braking. One is direct electro-pneumatic and indirect electro-pneumatic driver brake equipment. The third one is wheel slide protection. Fourth one is additional signal equipment, the high tone and low tone on. Bogie equipment is nothing but the calipers and wheel mounted brake disc. Bogie equipment. Then parking brake and air suspension. Today our agenda is these are the 6 categories: air supply, pneumatic brake control, wheel slide, additional signal equipment, bogie equipment, parking brake, and air suspension. Now I am going to give small introduction about how the brake system evolved from the past. The first they introduced the steam locomotive with coaches having a vacuum brake. Then move to the air brake system. From there they move to the electro pneumatic. Now train set coaches is having a electro pneumatic with load dependent braking. This is the evolution from the past. How the technology is growing up in the brake system. First, they introduced the vacuum brake in the steam locomotive and meter gauge coaches. After that, they moved to air brake system in the conventional coaches. Then they moved to EP brake in the EMU, local electric multiple unit. Similarly, air brake they moved to LHB, high speed trains. LHB coaches is having a disc brake system. Is panel mounted. Panel mounted component is a for compact design. They made the panel mounted brake system. Then they moved to electro pneumatic. Electro pneumatic brake is fitted in the EMU, electric multiple unit. After that, we are moving to train set coaches. Train set is having a electro pneumatic brake system with a load dependent. That means the brake force is not uniform in all the coaches. Based on the load of the coach, the brake force is decided by our system. What is a train concept in the formation? How they made in the formation in the train set coaches? The train set is having a 16 car unit and consists of 16 coaches. There are 4 basic units where is there. One is end basic unit, 2 end basic unit and 2 middle basic unit. Each basic unit is having a 4 cars. End basic unit having DTC and 2 MC and 1 trailer car. DTC is nothing but driving trailer car, where the motorman can drive the train from the driving end. The both end of the coaches having a DTC. The motor car with having a traction motor. The 16 car is a 50% of traction power is there. The balance is a trailer car. Next, each basic unit having a TC, trailer car. Trailer car fitted with pantograph equipment and a main transformer. Next, NDTC, the middle basic unit consists of 1 NDTC and 2 MC, 1 TC. This is a 16 car formation. The last 4 car is the end basic unit. Middle 4 car is the middle basic unit. In the how the brake system is fitted on the coaches, the categories we categorize the 6 or 7 categories. A for air supply, B brake control, C is a mechanical brake actuating component, D is the driver brake control equipment, G is the wheel slide protection, L is air suspension, T is a pneumatic signaling equipment, U is the auxiliary air supply for pantograph. Now in the 16 car, there are 4 cars having a air supply equipment. The main compressor with the delivery of 845 liters per minute. Oil-free compressor fitted in the 4 cars. 2 DTC and 2 NDTC. 2 DTC and 2 NDTC. Each basic unit having 1 air supply equipment. Next, B is a brake control equipment. All the car having a brake models fitted on all the coaches. Next, C is a mechanical brake actuating component. Each bogie having the mechanical brake actuating component. Compact caliper, wheel mounted disc. This is a mechanical brake actuating component. It is available in all the bogies. Each bogie having a 4 caliper. 4 is having a 4 out of 4, 2 is having integrated with parking brake. Mechanical brake actuating component is nothing but compact caliper and wheel mounted disc. See, each bogie having a 4 caliper. Out of 4, 2 is having a integrated parking brake system. In the each coach, 8 calipers are there. Out of 8, 4 is having a integrated with parking brake. That means 100% service brake available in the each coach, 50% available in the parking brake. Next is a D is a driving brake control equipment. It is available in the DTC car. The both end of DTC car having a driver brake control equipment. It's nothing but similar to A9 valve. A9 valve, we are giving a small compact driver brake valve. We can charge a BP or destroy the BP. It is a purely pneumatic. It is a purely pneumatic valve. You can control the formation. It's applying the brakes purely pneumatically. We can reduce the BP pressure or charge the BP pressure through the driver brake valve. It is only used during shunting purpose or somewhere in the OHE is not there. We want to move the train from yard to platform. Somewhere there is OHE is not there. For clearing the section, we are giving that driver brake valve. It's similar to A9 valve. We can charge the BP pressure or destroy the BP pressure. Next one is the G, wheel side protection equipment. We call it the WSP system. Here each axle having a wheel side sensor. Each axle having dump wall. The wheel slide protection is using to detect the slide and correct the slide. Wheel slide protection equipment. Next is the air suspension equipment. The primary suspension is damper. Secondary is our pneumatic air suspension equipment. Here each bogie is having 2 air spring below. We are charging the below based on the load through leveling valve. This is a air suspension equipment is having a leveling valve, duplex check valve, and is having installation lever with connected in the bogie lever. We can, for better comfort riding, this air suspension equipment is balancing the air spring both sides. Each bogie is having a 2 air spring. It controlling and balancing the coach level to platform level, also giving a better comfort ride to the train. Next is a pneumatic signaling equipment. It's having a 2 ons in the DTC car. High tone and low tone ons is there. It's called as pneumatic signaling equipment. U is the auxiliary air supply. It is available only in the TC car. Each basic unit is having a air supply for pantograph equipment. Air supply equipment for pantograph. It is an auxiliary compressor working with 110 volt DC. Each basic unit having 1 TC car. TC car fitted with pantograph and transformer, where we are using the auxiliary compressor fitted for rising the pantograph. This is how the brake system installed in the complete brake. A, air supply is nothing but compressor. B is a brake control, is a brake module available in all the underframe of the coaches. Next, C is a mechanical brake actuating component. Each bogie is having a caliper and disc. D is a driver brake equipment. Is similar to A9 valve for charging complete train through BP or destroying the BP through driver desk. It's fitted on the DTC car. Both end of DTC car having a driver brake control equipment. Next, G is a wheel slide protection. Each goes having a wheel slide protection. Each axle having a speed sensor and dump wall. Next is a L, air suspension equipment. Secondary suspension. Primary suspension is a damper. Secondary is air suspension. Next is a pneumatic signaling equipment. Each DTC is having a pneumatic signaling equipment. They are fitted with a high tone and low tone on. Both end of the driver cab is having a pneumatic signaling equipment. Next, U is the auxiliary air supply for pantograph. It's fitted in the TC car of each basic unit. Next, we move to next slide. How the system is electrical system, that electrical propulsion system, brake system, how interface. The architecture is so clearly from the train line to each unit. The top is a complete ECA network. Ethernet control network is available from train 1 to 1, end to end. From there, we are communicated through RS485 communication. RS485 communication. The last one, right side corner is a DDC car. Next is a MC car, TC car, and MC car. The complete train line ECA network is enabled from end to end. From there, they're connecting to PCU. That means passenger comfort unit is available in the DTC car. MC is having a main computer unit. It's connected through PCU and MCU. From there, we are connecting to our EBCU. EBCU is the electronic brake control unit for brake system. Each car is having a 2 EBCU, EBCU1 and EBCU2 for since the train set coach is having a bogie control brake system, in normally all the coaches are having a car control system. That means one EP control unit is there. It will control the both bogie. Here, train set coaches having a bogie control, so that we are having a redundant purpose. We are having two Becus and two EP control units. First, I told the Ethernet is connected to PCU and MC of propulsion system. From there, it connected to EBCU 1 and 2. From there, it connecting to. From there, it connecting. From there, connecting to the brake panel. Brake panel is the bottom of the. Cursor series. So 1 minute. Sorry for this. Cursor series. Okay, sorry. So, I can continue. The DTC is connected to PCU. From PCU is connected to EBCU. From there, it's connecting to the brake panel. Here, SCV is there. SCV is connected to the train line is BP pressure. SCV is nothing but similar to distributor valve. What are the functions doing in the distributor valve? Same function this SCV also will do.
Sir, can you please enlarge little bit? This PPT is not visible clearly.
I'm not getting your point, sir. Tell me, sir.
Just enlarge little bit this PowerPoint presentation. It is
One
components.
minute, one minute, one minute. Now you can. Oh,
Yes.
now you can see.
Yes. Thank you.
Okay, sir. The first top. 1 minute. Mouse point. Okay, sir. Can you able to see my cursor?
Now it is
आप
visible.
लोग का कसर देख रहे हैं क्या
Yeah.
सर कृष्णा सर
Yeah.
आप लोग का कसर देख रहे हैं क्या सर
Yeah, now I can start again. This is where I'm cursor is there. That is a complete Ethernet line from end to end. From there, connecting to PCU. PCU is a passenger comport unit in the DTC car. Same MCU is available in the motor car. From PCU, it's connecting the EBCU 1 and 2. EBCU is nothing but electronic brake control unit 1 and 2 for individual bogies. From there, EBCU1 is connecting to the middle skid of, that means brake panel, our EP panel. From there, it will go into bogies. Now, the trailer car is having a non-motor bogie. Motor car is having a motored bogie. The bottom of the deck, you can able to see the green color filled with is having a motor bogie. Trailer car, the DTC and TC is having a non-motor bogie. Next, I am moving to other slides. The brake system includes several features of the brake system. I'm going to explain in this slide. The compressor which are using is oil-free air compressor. Normally, compressor using in the locomotive and the EMUs is an oil compressor. The maintenance are more. Every 18 months or 1 year, you have to change the oil. Similarly, oil will go to the pipeline and will cause the malfunction of the brake system. Here we are using oil-free compressor and air dryer unit. It's a brake system fitted with electro pneumatic and microprocessor control direct service brake. Also, we are having the indirect brake system. That indirect brake is applied for redundancy reason or an emergency application in the event of failure of direct service brake. If any one of the coach is having a failure, the both Becus or anything is service brake is failed, our emergency brake will take care in the indirectly to stop the train. Similarly, tumbling mode operation on the based on brake pipe is purely pneumatic brake. From the driver brake valve, we can operate. We can control the tumbling mode operation by reducing the BP pressure and charging the BP pressure. Next, wheel mounted disc with compact caliper. The LHB, whatever you've seen, is the axle mounted disc. Here we are using the wheel mounted disc. The advantages over axle mounted and wheel mounted is we can stop the train with compared to axle mounted, stopping distance is less in the wheel mounted disc with high speed. Then designated quantities of compact brake caliper units having a spring-operated parking brake portion integrated. These are the features of Train 18. The piston compressor, oil-free compressor with air dryer, electro pneumatic with microprocessor control, direct service brake, automatic indirect brake is applied as a redundancy reason. If any failure in the brake system, that means during service application, any failure is happened, indirect brake, that means the emergency brake will apply for redundancy reason. Also, we are having in case of the train is running the over speed, it will apply the emergency. TCMS will induct to trigger the emergency brake loop, and the emergency brake will apply. This is also indirect
Sir,
brake.
excuse me, sir.
Yeah, tell me, sir.
Sir, can you go bit slower, sir? Please.
Yeah, okay. Next is a towing mode operation based on indirect pipe. Next, wheel mounted brake disc with compact caliper unit. Next, brake caliper inbuilt with parking brake.
How wheel mounted disc brake is advantageous over axle mounted brake disc?
Yes, sir.
How wheel
Sir,
mounted disc brake system is advantageous?
sir, actually
Sir,
the
what are the
braking,
advantages of wheel mounted braking system, sir?
The wheel
sir,
mounted brake disc. The wheel mounted brake discs compared to axle here, we are directly controlling the wheels of the axle. There we are controlling the axle. That axle rotation we are controlling here directly. We are applying the brakes on wheel disc. It means the wheel. So that compared to axle mounted brake, the wheel mounted brake system is having a less stopping distance. This is the advantage. Next, I am going to explain this slide. Electrodynamic brake is a motor car, is the main brake system. Here we are having a 8 motor car and 8 trailer car. Motor car is having a traction motor. That means we are having regenerative features. That means dynamic brake is a preference, first priority in the motor car. Trailer cars are having a friction brake. In case of failure in the dynamic brake, the friction brake will take over. What are the friction brake performance available in the Trainset coaches? Service brake is purely EP brake, and service brake at times partial ED brake. That electrodynamic is failure, our service brake will take over in the motor car. Then emergency brake, parking brake, and stopping and holding brake. These are the functions of brake system. These are the brake system will control. These are the brakes. Service brake with at time partial ED brake is failure. Emergency brake, parking brake, and stopping and holding brake. I'm moving to next slide. Now first is a service brake. How service brake is applying from the master controller. From the master controller, the driver is moving the handle in the braking zone. From TCMS will calculate the demand and give to EBCU. EBCU is nothing but electronic brake control unit. It will calculate the brake cylinder pressure based on the load. Then it will give to our EP coil. There are 2 coils are there. One is charging coil, another one venting coil. It will trigger based on demand. If you want to apply the brake, it will trigger the charging coil. If you release the brake, it will trigger the release coil. That means venting coil. It triggers the coils. From there, it will pilot pressure. The pilot pressure will generate. It will go to load dependent valve. In the load dependent valve, having a pressure of bogie. Each bogie average pressure. In individual bogie, there are 2 acting is there. From there, it will calculate the below pressure based on the load, and it average it and give to our particular bogie depot. From there, we are generating the pilot pressure to relay valve. This is the pilot pressure going to apply the brake cylinder pressure. Once this pilot is generated, the relay valve will allow MR how much pilot escape, that much MR will go to the brake cylinder. This is a concept, the basic concept of how service brake is applying Trainset coaches. From the master controller, driver moving on to braking zone. From there, it will TCMS will calculate the demand and will give to EBCU. EBCU will calculate the brake cylinder.
Excuse me, Arun sir, just please can you repeat this service based application concept?
सर मैं रिपीट करता हूँ अरुण थोड़ा கொஞ்சம் ஜூம் பண்ணுமா நான் ரிப்பீட் பண்றேன் ஜூम பண்ணுமா अरुण लाइटा கொஞ்சம் ஜூம் பண்ணுமா सर एक्चुअली क्या होता था whenever ब्रेकिंग का कमांड आ चुका है बेकू का पास माइक्रो प्रोसेसर के पास आ चुका है बेकू व्हाट विल डू इट विल रिसीव द कमांड व्हाट इज द परसेंटेज ऑफ ब्रेक शुड बी अप्लाइड एंड व्हाट इज द लोड वो क्या होता है जब ब्रेक डिमांड आने के बाद माइक्रो प्रोसेसर सिग्नल देते हैं चार्जिंग एंड वेंटिंग मॉल को दैट इज A1 एंड A2 को सिग्नल देते हैं कितना ओपन होना चाहिए बोल के वंस इट हैज बीन अचीव्ड दैट कैन बी सेंस्ड थ्रू J1 का थ्रू वापस सेंस कर दे मेरा डिमांड कितना था मैं कितना ब्रेक होना चाहिए वो उतना आ गया पैरेलली क्या हो रहा है टी प्रेशर द बॉटम लाइन ग्रीन लाइन उधर से गाड़ी का बेलो का लोड प्रेशर सेंस होते हैं एंड ये दोनों एवरेज हो जाते हैं बोगी 1 का कितना है राइट बिलो का कितना है लेफ्ट बिलो का कितना है वो दोनों का मीन लेके मीन देते हैं इसके लिए क्या होता है आपका यूनिफॉर्म ब्रेक फोर्स नहीं रहेगा लोड का हिसाब से ब्रेक रहेगा दैट इज अ लोड कैलकुलेटेड ब्रेक सिस्टम रहेगा सर ब्रेक रहेगा वो आएगा इसमें के सेंसर का थ्रू के इज नथिंग बट इज सेंसर इट इज गिव्स फीडबैक टू द माइक्रो प्रोसेसर जाएगा हाँ कितना लोड है इतना ब्रेक अप्लाई होना चाहिए जब ये पायलट जनरेट होने के बाद दैट पायलट विल बी डिलीवर्ड टू एफ लोड डिपेंड वॉल इधर क्या होता है सर लोड का सेटिंग होता है कितना लोड प्रेशर है तो कितना आना चाहिए मतलब मान लीजिए अभी टायर वेट है गाड़ी पर लोड ही नहीं है हल्का सा ब्रेक लगेगा ज्यादा लोड है फुल लोडेड कंडीशन वो टाइम में कितना ब्रेक होना चाहिए वो आएगा उसके हिसाब से दैट पायलट विल पास थ्रू LDV दैट इज एफ लोड डिपेंड वॉल उधर से KR6 को जाएगा KR6 में क्या होता है सर इट्स रिले वॉल कितना प्रेशर आएगा उतना जल्दी ब्रेक सिलेंडर के पास जाएगा अरुण एक स्टार्ट पड़ेगा सर कोई डाउट है सर इसमें
Okay, thank you.
सर कोई डाउट है सर
No.
अरुण स्टार्ट पड़ेगा
Yeah, we are moving to next slide. Yeah. Second one is emergency brake. This is an emergency loop wire is available in the complete train line. Initiated if you can apply the emergency brake through master controller also. If emergency brake loop is open, the emergency brake valve available in the unit. That means in the BCU is having a emergency brake valve is always energized. The loop, that emergency brake loop is triggered. That means if de-energized, emergency brake will apply in the coaches. This emergency brake also is having a load corrected via load dependent pressure limiting valve in the brake loop. This is a logic. You see, there is a push button available in the emergency, the driver desk. The driver is pressing the emergency button. The loop, emergency safety loop will trigger. That means it will de-energize. Once it de-energize, the emergency magnet valve available in the BCU will get de-energized. It will allow directly MR pressure into the pilot to the relay valve. That means through load dependent valve, it will go to relay valve. From there, BC pressure will come. This is the concept of emergency brake. Even though emergency brake also load dependent valve. That means load corrected emergency brake will apply in the individual bogies. Next is a towing mode operation. The towing mode is a purely pneumatic operation. No electricity is required. Only MR BP is required. From MR, we are giving to this driver brake valve. From there, handle is in release position. It will charge a BP 5 kg to complete BP train line. This is a towing mode. Towing mode, we are using a driver brake valve. Is having a 3 position. Middle one is the neutral position. Towards the driver, towards the front is a braking and backward is a release. There are 3 positions you are having. If you move handle towards forward means the BP will destroy that SCV. That means distributor valve. Similar to distributor valve, SCV is a model name is SCV. It's fitted in all the coaches. It will sense the BP droppage and it will give the pilot to relay valve. From here,
one second. सर एससीवी कुछ नहीं है सर, ये नॉर्मल डिस्ट्रीब्यूटर वाल्व है। डिस्ट्रीब्यूटर वाल्व में क्या होता है सर, व्हेनेवर आप बीपी कम कर रहे, सीआर मतलब अप करेगा पिस्टन को, देन ब्रेक विल बी अप्लाइड। सेम कॉन्सेप्ट इज एप्लीकेबल हियर। ये में क्या होता है, इट्स एन कॉम्पैक्ट डिजाइन। एससीवी जो कुछ है डीवी जैसे फंक्शन करेगा, बट कॉम्पैक्ट डिजाइन है सर। सर कोई डाउट्स है सर इसमें? कृष्णा सर कोई डाउट्स है?
सर अनिल सर,
हाँ जी बोलिए सर।
सर एक जो पहले वाला थोड़ा सा हमको कि ये जो लोड डिपेंडेंट जो ब्रेक पावर आप कैलकुलेट करके अप्लाई करते हैं,
हाँ सर।
कोच कोच बेस पे अलग अलग कोच के हिसाब से अलग अलग कोच के अलग अलग ब्रेक फोर्सेस भी होता है, या टोटल एवरेज करके?
सर सर आपका सवाल बिल्कुल सही है। अलग अलग कोच में अलग अलग लोड रहेगा। मान लीजिए एक बोगी में 10 आदमी खड़ा है, दूसरा बोगी में बिल्कुल जीरो है, उसमें अलग प्रेशर ब्रेक अप्लाई हो जाएगा, इसका अलग प्रेशर ब्रेक अप्लाई हो जाएगा। बट जो कुछ ब्रेकिंग का कंफर्ट रहता है वो इक्वल रहेगा। ऐसा नहीं है मतलब एक में जर्क आ रहा है दूसरा में, ऐसा नहीं है। कितना लोड है उसके हिसाब से ब्रेक रहेगा। एज पर द यूएससी स्टैंडर्ड हम लोग ने ऐसा बनाया, इसके लिए इसमें लोड कैलकुलेटेड ब्रेक सिस्टम बोलते हैं सर। एंड अपना बेको सिस्टम क्या है, ब्रेक कंट्रोल यूनिट। अंडर फ्रेम पे जो कुछ था ब्रेक कंट्रोल ईपी यूनिट का कंट्रोल होते हैं, बोगी का एक बोगी के लिए एक यूनिट, एंड इलेक्ट्रॉनिक्स ऑल्सो एक बोगी के लिए एक यूनिट। इसका मतलब एक ब्रेक माइक्रो प्रोसेसर इलेक्ट्रॉनिक्स यूनिट जो कुछ रहते हैं वो कंट्रोल करेगा एक ही बोगी को, और दूसरा बोगी के लिए दूसरा। जब कोई फेलियर आया, बेक्कू में कोई फेलियर आया, कुछ काम नहीं कर रहा, कोई फेलियर आया, देन बेक्कू 2 विल कंट्रोल बोथ, टोटल कोच को कंट्रोल करेगा। नहीं बेक्कू 2 प्रॉब्लम हो गया, बेक्कू 1 कंट्रोल करेगा दोनों को। इसके लिए हम केएसएन नेटवर्क यूज कर रहा था। हेलो सर, सर क्लियर है?
यस सर, यस सर।
अरुण कैन यू स्टार्ट मा?
Yes, sir. I want to tell now Anil has explained each bogie is having a different pressure. In normally the other coaches, LHB or conventional coaches, you are having the uniform brake force in all the bogies. Here, due to load dependent system, individually bogies having an individual load. Based on the load, brake force will vary. It is the advantage over the other system. Next is a fourth one is a parking brake. Parking brake application is a brake application for a stopping a stationary train from rolling under set condition, as long as required until the brake is released. Is a stationary brake. If you want to hold the train, if the train is due to for stopping the train, you want to stop the train off or the signal for signal clearance or somewhere in the yard, you have to apply the parking brake. Our parking brake is a purely it's a electrical signal. Is a driver there. There are two buttons are there. One is a parking brake apply button and release button. Based on the buttons, you once you press the apply button, the apply coil of the parking brake will trigger. It will exhaust the R. Normally, the difference between service brake and parking brake. Service brake, if you give the air to cylinder, brake will apply. The parking brake is ulta. Ulta means is a spring loaded. Whenever is air taken from parking brake, air is exhausted from parking brake chamber, it will air exhausted from the parking brake chamber, it will release the parking brake. Sorry, it will apply the parking brake. Once air given to the
सर एक्चुअली सर्विस ब्रेक में क्या होते हैं, नॉर्मली ब्रेक्स में क्या होते हैं सर, जब हवा जाएगा सिलेंडर के अंदर ब्रेक अप्लाई हो जाते हैं। पार्किंग ब्रेक में क्या है सर, इट इज रिवर्स ऑफ दैट वन, बिकॉज इट इज एन मैकेनिकल ब्रेक, स्प्रिंग एक्चुएटेड ब्रेक। स्प्रिंग में जब हवा नहीं है ब्रेक अप्लाई हो जाएगा, स्प्रिंग में आपने हवा दे दिया देन ब्रेक्स विल बी रिलीज्ड। सो इसमें क्या होता है सर, जब गाड़ी आपने 10 दिन के लिए कड़ा में खड़ा कर दिया, एक जगह में खड़ा कर दिया, उसमें बिल्कुल प्रेशर नहीं है, वो टाइम क्या होता है सर, गाड़ी रोल बैक हो सकते हैं, बिकॉज धीरे धीरे प्रेशर का पाइपेट का प्रेशर से रिलीज होकर रोल बैक हो सकते हैं। पार्किंग ब्रेक से क्या हो जाएगा सर, वो इट विल बी स्टेशन इन दैट पर्टिकुलर प्लेस। जो कुछ कोस्टल एरिया का कोचेस के लिए ये बहुत इंपॉर्टेंट होते हैं, एंड इट्स एन सेफ्टी पॉइंट सर। सर कोई डाउट है सर?
लेकिन सर ये जब यार्ड में खड़ा होगा या 10 दिन के लिए होगा तो उस समय तो सप्लाई हमारे पास होगा नहीं। ये पार्किंग ब्रेक के लिए, जो पार्किंग ब्रेक के लिए जो मैकेनिकल ब्रेक है, तो इसको जो एक्चुएट करने के लिए क्या वो स्प्रिंग जो स्टिफनेस इसकी मैकेनिकली जो फोर्स है वो वैसे ही बना रहेगा, उसमें कुछ
सर
रिड्यूस नहीं
बिल्कुल
होगा।
सर, बिल्कुल समझ गया आपका बात, मैं समझ गया सर। द पार्किंग ब्रेक मैनुअल कैन बी ऑपरेटेड, इलेक्ट्रिकल भी ऑपरेट कर सकते हैं, मैकेनिकल भी ऑपरेट कर सकते हैं। जो कुछ पुश बटन दिखा रहे लाल वाला पुश बटन, बाय अप्लाइंग दैट वन ब्रेक्स कैन बी रिलीज्ड। हमेशा क्या हो रहा है सर, जब गाड़ी पे आपने सप्लाई निकाल दिया, 10 बार का एमआर प्रेशर रहेगा तो ब्रेक्स विल बी इन रिलीज कंडीशन। धीरे धीरे प्रेशर जब गिर जा रहे, नहीं तो ड्रॉप हो रहे 10 दिन के कोई लीकेज की वजह से, फिर क्या हो जाएगा सर, प्रेशर कम हो जाएगा। जब प्रेशर कम हो जाएगा तो अपना ब्रेक लग जाएगा सर, पार्किंग ब्रेक लग जाएगा। हेलो सर।
ओके ओके सर,
मैं वो नहीं बोल रहा, जब गाड़ी मूव
रिलीज
करना है यार्ड में बिना प्रेशर के है तो मूव नहीं कर सकते हैं।
हाँ सर, बिल्कुल वही है सर, वही इट्स सेफ्टी फीचर सर। मान लीजिए आपने कोस्टल एरिया में गाड़ी खड़ा है, ट्रैक बहुत अच्छा लेवल में रहेगा, बहुत स्मूथ रहेगा गाड़ी, मतलब थोड़ा सा आप हल्का सा धक्का दे तो रोल हो जाएगा। वो जगह में आप चेन से बांध के कर रहा था, कभी कभी होता था ऐसा, ऐसा कोस्टल एरिया मुंबई साइड में ऐसा करता था। पार्किंग ब्रेक से क्या हो जाएगा, जब गाड़ी पे प्रेशर नहीं है, ब्रेक्स विल बी अप्लाइड, दैट्स व्हाई इट कॉल्ड एज अ पार्किंग ब्रेक। हमेशा क्या होता है सर, प्रेशर रहेगा, ब्रेक अप्लाई होगा। कोई लीकेज का कारण, कुछ कारण का वजह से, नहीं तो 10 दिन खड़ा है कोई रीजन का वजह से, क्या हो जाएगा, धीरे धीरे प्रेशर रिलीज हो गया तो रोल बैक होने के लिए चांसेस है सर। ट्रैक से ट्रैक का कितना अच्छा कंडीशन रहेगा, बिकॉज हमेशा गाड़ी चल रहा है, इसके लिए बहुत स्मूथ रहेगा। धीरे धीरे पार्किंग ब्रेक से क्या हो जाएगा सर, जब प्रेशर नहीं है, स्प्रिंग विल बी एक्चुएटेड, इट विल अप्लाई ब्रेक्स ऑन द व्हील डिस्क, सो गाड़ी थोड़ा भी हिलेगा नहीं। एंड इट इज इन डायगनल, एक एक्सिल के लिए एक, इसका मतलब एक बोगी में ऑपोजिट ऑपोजिट में रहेगा सर।
सर
सर
इसको
अगर हम
अगर मान लीजिए यार्ड में गाड़ी था, इसको हमें शंटिंग करके कहीं ले जाना हो दूसरे यूनिट से, तो जब तक हम कंप्लीट रेट में न्यूमेटिक सप्लाई या सप्लाई को चालू नहीं करेंगे, तब तक हम रेट को मूव नहीं कर सकते।
बिल्कुल सर, बिल्कुल। बट वो टाइम में आपको शंटिंग में मूव करना होता, मतलब मान लीजिए थोड़ा सा मूवमेंट करना होता है। पहली रीजन 10 बार का प्रेशर लेकर आने पड़ेगा, शायद नहीं है। आप एक काम कर सकते हैं, मैनुअल रिलीज है सर, पार्किंग ब्रेक का मैनुअल रिलीज है। आप गाड़ी को रिलीज करके मतलब कोई जगह से वर्कशॉप तक लेके जा सकते हैं। एक मैनुअल रिलीज हैंडल भी दिया था, वो नीचे चैप्टर में आ रहे सर वो।
यही पूछना था, ये मैनुअल रिलीज
ना
है
ना
ना सर?
है सर, बिल्कुल है सर, बिल्कुल है सर। अरुण स्टार्ट பண்ணீங்க ஸ்டார்ட் பண்ணீங்க अरुण।
Yes, this is a parking brake magnet wall. Also, isolation of parking brake. We're having the electrical feedback isolating cock. If you isolate, the feedback will go to DDU. DDU means driver display unit in the DDC car available. Once you isolate the cock, the pop-up message will show the particular car is a parking brake isolation cock is isolated. Then the pressure switch is there. The pressure switch to indicate the DDU, the parking brake is applied or released. The feedback through the pressure switch go to DDU. These are the three components available in the parking brake system. One is a parking brake impulse magnet valve, is apply and release coil. It is also having a knob, mechanical knob. You can manually apply and release the parking brake. And the isolation cock with the feedback. And the pressure switch indicating the parking brake apply and release. Here, normally the EMU, there are two cylinders are there. Now, BC is for brake cylinder, we are using a single cylinder. For parking brake also, they are putting the separate cylinder. But here, single cylinder is integrated with parking brake. No need to provide separate cylinder for parking brake. Each axle having a one parking brake cylinder integrated compact caliper integrated with parking brake. These are the four brakes. First is a service brake. Next one is a emergency brake. Third one is a wing brake. It's a purely pneumatic brake. And final, last one is a parking brake. Next, we're going to detail. Yeah.
Sorry, you said for parking brakes it is completely spring loaded, spring actuated, no sir? But why there is a need of cylinder?
No. Cylinder is nothing but we are having a single cylinder.
Sir, to compress the spring, some cylinder pressure is required, so it has been kept with a diaphragm. स्प्रिंग नीचे रहेगा, ऊपर पिस्टन रहेगा, फिर हवा से हम उसको प्रेशर कंप्रेस करके रिलीज रखेंगे। जब हवा बाहर निकल जाएगा तो स्प्रिंग एक्सपांड हो जाएगा। मैं ओपन रखूंगा तो वो बिल्कुल बाहर आ जाएगा ना सर। हेलो सर। सर आप क्लियर है सर? आपको क्लियर सुन रहे सर?
Sir, can you explain it again?
हाँ सर। नॉर्मल इट्स स्प्रिंग एक्चुएटेड बोला था सर। एक्चुअल रीजन ये था, स्प्रिंग को कंप्रेस करने के लिए प्रेशर तो चाहिए सर, इसके लिए वो सिलेंडर चाहिए, एक डायफ्राम भी रखा है उधर इसको कंप्रेस करने के लिए। जब ब्रेक रिलीज हो जाएगा, जब मैं हवा को हटा दिया, देयर इज अ प्रेशर 10 बार प्रेशर से 0 आ गया, फिर क्या हो जाएगा सर, प्रेशर जब जाएगा तो स्प्रिंग विल एक्सपैंड बिहाइंड दिस वन व्हाट वी कॉल डायफ्राम पीछे रहेगा, पीछे रहकर उसको दबा के ब्रेक अप्लाई करेगा। नॉर्मली क्या होता है, पिस्टन का ऊपर एक डायफ्राम रहता है, वो कंप्रेस करके 10 बार प्रेशर देकर कंप्रेस करके उसको रिलीज रख लेता हूँ। जब प्रेशर को हटा दिया, पार्किंग ब्रेक आप अप्लाई कर रहे हैं, प्रेशर हट जाएगा, सो स्प्रिंग विल बी एक्सपैंडेड, सो इसके लिए सिलेंडर चाहिए सर उधर। सर
that
clear
means
है?
that
हाँ
means
सर,
the same brake pads with same
Sir,
caliper you are using for the electro pneumatic.
बिल्कुल बिल्कुल सर, बिल्कुल सर। सर एक्चुअली इसके लिए मेरा कोलीग मिस्टर अरुण कुमार हैज एक्सप्लेन्ड, इट इज एन इंटीग्रेटेड, द सर्विस ब्रेक इज हैविंग एन इंटीग्रेटेड पार्किंग ब्रेक। इसका मतलब है एक ही कैलिबर का अंदर 2 चैम्बर है, तो दोनों सेपरेट, वन इज सर्विस वन इज पार्किंग। सर
कि
सर
जब
Okay,
तक
okay.
एम्बर प्रेशर रहेगा
कैन यू हियर
तब
मी?
तक काम कर नहीं करेगा ब्रेक
नहीं करेगा। हाँ सर, अरुण स्टार्ट பண்ணிக்கங்க ना।
Yeah. So the cylinder is having a two chamber. One chamber is having service brake, another one chamber is a parking brake. In the parking brake nature is in the service brake, if you give the air to chamber, it will apply the brake pad holder. When the parking brake is spring actuated, if your air is from chamber, your air is exhausted, the spring will compress. That means it will release the parking brake. If your air once air is given, the spring will compressed. This is a logic. Two chambers having two single cylinder, there are two different chambers. One chamber is having a piston which apply the parking service brake. Other one is a spring actuated. This is the difference. Next one is a air supply system. Now first we've seen the first air supply. Air supply we're using the main compressor which operate in the 415 volt 3-phase. Also it is having a hair dryer unit. From air dryer, it will deliver the air to the reservoir. Reservoir is having a 200-liter capacity. From there, it will charge a complete train line. The MR is working pressure in the train head is 8.5 to 10 bar. First one is a motor, 3-phase ABB motor. It's connected with the compressor. From compressor, a flexible hose is there. It's going to the air dryer unit. Before air dryer unit, there is a safety valve. If compressor is air dryer is stroking or compressor is continuously running, the safety valve blow at 12 bar pressure. From there, it air dryer. You know very well, air dryer is a dual chamber air dryer unit. Drying and regeneration parallelly done in the atmospheric air. More than 65% of humidity is there. To reduce the humidity level, is air dryer using after air dryer, your humidity level is the delivery of air is less than 35%. From there, final filter is there. From there, it's stored in a reservoir. Before reservoir also, we are providing one safety valve, 10.5 bar. Normally, this compressor cutout range is 8.5 to 10 bar. Once the pressure is filled to 10 bar, compressor automatically switch it off. When pressure less than 8.5, compressor automatically switch on and to start filling up to 10 bar. The compressor TCMS is controlling this compressor on off based on pressure level. If you pressure reach to 10 bar, compressor switch off the TCMS fuel contactor will switch off. If you pressure below 8.5, again compressor will switch on and it will fill the air. In the train 16 car, there are 4 units having the main compressor. During initial charging from 0 to 10 bar, all 4 compressor will work. After filling the 10 bar, once the pressure consumption will come down 8.5, that time only 2 compressor will work. The alternate days. The first day only DTC and NDTC one will work. Next day another NDTC, another DTC will work. Alternatively will work. During initial charging, all 4 compressors run and fill the air fastly. After charging 10 bar, once the pressure is consumed, it comes to 8.5. Then again switch on. That time only 2 compressors will work in the formation. That is controlled by TCMS. The bottom of
this
reservoir.
logic, This logic we call as a compressor management to control the duty cycle of the compressor, because चारों compressor एकड़ा जाएगा तो आपका maintenance call ज़्यादा हो जाएगा on Monday, or for example even days or days, पहले compressor and DTC1 and TC2, and second day for Tuesday DTC2 and TC2, ये कंप्रेसर चालू होगा। इसके लिए आपको क्या हो जाएगा सर, यूनिफॉर्म रहेगा, ऑपरेटिंग आवर मीटर भी अपना पास है, सो कितना कंप्रेसर कितना घंटा तक चला है वो भी मेंटेन कर सकते हैं। आपका मेंटेनेंस के लिए इजी रहेगा, ऐसा नहीं है बेस्ड ऑन द किलोमीटर्स आप मेंटेन करने पड़ेगा, वो मतलब इनबिल्ट है सर, मतलब ऑपरेटिंग आवर में आप चेक कर सकते हैं, एंड ड्यूटी साइकिल आपको मतलब कंप्रेसर का लाइफ बढ़ा के दे देगा। इसके लिए तो ये लॉजिक इम्प्लीमेंट किया है सर। अरुण
Yeah. Sir, from the bottom of the reservoir, where are you having auto drain wall? Normally, in the air storage, after storing air, sometimes the condensate water available in the bottom of the reservoir, we are using the drain wall. Drain wall connected to the magnet wall. Whenever compressor is switching on or switching off, some certain 10 to 10 seconds, 10 seconds, this coil will energize and pressure will enter in the drain wall. It exhausts whatever water available in the bottom of the reservoir, will exhaust through this drain wall. Once whatever condensed water available in the bottom of the reservoir exhausts through the drain wall, once whenever compressor is switching on and off, then the same line we are giving the one pressure switch is 7.5, cut out is 10 bar. We are using here pressure sensor is there. Pressure sensor is the primary. Secondary one is a pressure switch. For redundant purpose, we are using both sensor and pressure switch. Sensor is always read the pressure. Whenever compressor MR pressure below the 8 kg, it will switch on the compressor. It will read 10 kg switch off. The same is not happened. Even though after less than 8 kg, compressor is not starting. Once it reaches to 7.5, the pressure switch will indicate to compressor on TCMS, to indicate to TCMS to switch on the compressor. This is a secondary. Primary is a pressure sensor. Secondary one, this pressure switch. From there is connecting. The MR air is connecting to the train line. Before that, one isolation cock is there. It is also having the electrical feedback. Its same will connected to the DDU. If you complete air, this air supply unit is having a leakage or some malfunctioning, you can isolate through this isolating cock. Next, the various parts of our compressor, main compressor. This is a three-phase motor, ABB make we are using in this main compressor. This is a suction filter which is connected with vacuum indicator. This one is a filter element. This is a suction pipe. It is sucking the air from the atmospheric air. These are the cylinder. Here we are using the two-stage compressor. That means one LP and HP. We are using two LP cylinder and one HP cylinder. Sucking air will go to the piston chamber. After compressor, it will come to LP cylinder. From there, it will go to the intercooler. After intercooler, it comes to high pressure cylinder. From there, it is going to aftercooler. From there, it connected to the delivery. This is the various components, the compressor. Motor, three-phase motor, vacuum, suction indicator, suction filter with vacuum indicator. If these filters are soaked, the vacuum indication indicate, that means the color will change. Normally, the white color. If the filters are soaked, the red color knob, red color indication will show in the vacuum indicator. After replacing or removing the soak, you can reset this vacuum indicator. Next is the cylinder. Two cylinders are there. That side one cylinder, this side two cylinders are there. One LP and one SP. Opposite side one LP cylinder is there. It is the inter-after cooler. Then cooling fan. The technical features of a compressor is air delivery 845 liters per minute. Rotation speed 1455 RPM. Service temperature range, it will work from -10 degree to +50 degree. Working pressure is 10 bar. Compressor two stage, that means LP and HP. Total number of cylinders we are using is 3 cylinders. Frequency of supply is 58. Cooling airflow rate 0.64 meters cube per second. The total weight of compressor is 200 kg. These are the additional technical features. Is what I am explained that is available in this slide. Two cylinder, so it means two stage, 3 cylinder, optimal cooling. All the cylinders are having optimal cooling. the compact construction, no extra frame is required, one single frame, both compressor and air dryer unit mounted. The low vibration and low noise emission is oil-free compressor. No oil contamination available in the airline. Also, it's durable and maintenance-free. Coupling between motor and compressor is a great original rigidity couple. Maintenance is every 1,000 of compressor operating hour or 12 months. You have to check this basic functions of compressor. The compressor giving air or good delivery air. Also, we have to some water separator and filters are there. Every 12 months, you have to change the filter element. After 3,000 operating hours, 2 years, to check wear and tear of drain walls and that ribs, the cooling, the cylinder and motor area cooling ribs are there. Any wear and tear is there you want to check. Then 8 years only maintenance. We are recommending 8 years. Once in 8 years, you have to overall complete compressor unit. This is a safety valve. You see there are two conditions of the safety valve. One is closed condition, other one is the open condition. Up to stated pressure. If I have set a safety valve at 10.5 bar, up to set 10.5 bar, the valve sheet is closed. If pressure goes beyond 10.5 bar, it will open the valve sheet and will exhaust. This is the purpose. Purpose of safety valve is the pressure level will not allow beyond the level. Otherwise, the pipe will burst. The leakage will start. It will malfunction the equipment. To avoid that, we are using the mechanical safety valve with set at pressure level. 10.5 bar up to 10.5 bar is the valve sheet is closed. Beyond 10.5 bar, the valve sheet will open. Pressure will continuously exhaust and the MR pressure will drop. Next is the drain valve. I told no, bottom of the reservoir, some condensed, the possibility of condensed water. To exhaust the condensed water, we are using the drain valve. This is a drain valve, drawing of drain valve. Here, jet is a pilot port. We are controlling through auto drain valve magnet valve. This line, one magnet valve is connected. The branch from MR line. Whenever is compressor switching on or switching off, we are giving small pulse, short duration of pulse through coil. The coil will allow the MR pressure. It will close the main MRR and will exhaust the exhaust port. Whatever water is available in the exhaust port, it will exhaust through the bottom. Also, manual release is there. You can the spring loaded manual release. You can pull. You can drain out the complete water. The drain valve. This is the drain valve. Now it is a dual chamber air dryer unit. The two towers are there. Each both towers is parallelly work. One is drying phase, another one is a re-drying phase. Here is the timer cord is available. Each tower will continuously work 120 seconds. Complete cycle is 4 minutes. First tower will work 2 minutes. Then it switch over to other tower. Other tower will work 2 minutes. The complete cycle for drying and regeneration 4 minutes. The bottom end duplex piston valve is available. It controlling the tower changing from one tower to other tower. Also, is having a pressure switch. If any one continuously one tower is working more than 2 minutes, also if another is not changing the tower, it will indicate the TCMS. There is a problem in the air dryer to isolate the complete compressor. That compressor will not run unless otherwise we are make ready to this air dryer. There are technical features. I told you observation dryer, dual chamber air dryer. That means the medium is desiccant. Each tower is having a 4.3 kg desiccant is available. This is a molecule. It will absorb the air. And drying and regeneration run in parallel. Integrated oil separator also is there. It's a pneumatic control drain valve with the silencer. The bottom of the tire is a drain valve. Is a drain valve with silencer is available. Permissible working pressure is 10.5 bar. The air dryer will work temperature from 0 to 50 degree. Maximum inlet temperature is plus 60 degree. Relative humidity after air outlet is less than 35%. Cycle time of air dryer is 4 minutes. But desiccant is per tower is 4.3. Also, it will indicate to TCMS. If tower status, either which tower is working. If tower is not changed, it will indicate to TCMS there is a problem in the air dryer. You isolate the complete air supply unit. The maintenance only once in a year you want to check the dew point meter with out delivery of air. Whatever delivery is coming less than 35% of humidity level or not, you want to check with functional testing with pressure dew point meter. Every 2 years you have to check the leakage, any leakage or functional testing, cover changing, or all the things you want to check every 2 years. Where then every 4 minutes that cover changing is happening, that the control magnet valve with timer cord is working fine or not, we have to check. These are the basic maintenance for the compressor. First, now you've seen whatever is seen is a main compressor. It main compressor will work 415 supply, 3-phase 415 supply whenever is OAC is available. Now this is air supply for pantograph, auxiliary supply. If you switch on the train, no air is available. Only you switch on the train, battery supply only available. Based on the battery supply, this auxiliary air supply will run. That means the compressor, baby compressor will work 110-volt DC supply from the battery. Once once you switch on the battery, that means switch on the train, the compressor will start run and it will develop the pressure 6 to 7 bar for using for raising the pantograph. Only for pantograph application, we are using this auxiliary air supply system. It's working in 110-volt DC supply. Once switch on the train, the supply air compressor, auxiliary air compressor will get supplied. It will run. It will develop the pressure 6 to 7 bar. The pressure will connect it to pantograph. Once the pressure is reached, if you switch on the pantograph on, the panto will rise and VCD will close. After VCD closed only, you get the OEC supply to the transformer. From transformer, it will flow to the other subsystem, auxiliary converter, line and traction converter, all other subsystems. Whatever is available in the train, it will get the supply through the OHC. This is a auxiliary supply only for pantograph. Similarly, the same MR, once the pantograph is right, after that main compressor will take care. Once the pantograph right, you will get the power supply, the transformer. Transformer will give to auxiliary converter. Auxiliary converter will convert 415 supply, 3-phase supply to main compressor. Main compressor will start run and it will fill up the air. Up to main compressor start, this auxiliary will give the air to raise the pantograph. Similarly, once the main compressor runs, main compressor also will fill into the air to pantograph. These are two isolation cogs. To isolate, in case of small person, you can isolate through these two cogs. And then pressure switch is available. It will switch on and switch off 6 to 7 bar. Then switch on and switch off the compressor. The pressure switch available 6 to 7 bar. It will control the pressure switch. Then it will control the auxiliary system. Now auxiliary compressor also oil-free compressor. No oil is required. It's a single stage battery operated compressor. It is using only for pantograph rising purpose. The auxiliary compressor model V10T is a compact oil-free one cylinder. That means single stage one cylinder piston compressor directly attached to permanent magnet of DC motor. The compressor will work DC motor. It's supply of 110-volt DC. The main compressor will work 3-phase 415-volt AC supply.
Sir, hello.
Yeah.
Sir, the auxiliary compressor which is used for raising the pantograph is always run through DC supply, or the main power supply is used.
No, only DC supply. No, you understand? No, once the train is switched on, you will not get the 450 supply immediately. Once the panto rise, it will touch to OHC. Once OHC give the power to the transformer, then only auxiliary converter will start running and it will give the 415. If without air, you cannot raise the OHC.
Okay.
Without air, you cannot raise the OHC. For rising the OHC, we are using the auxiliary converter with the DC supply, 110 volt. Always the DC supply is available in the battery.
Okay.
Battery box.
Okay.
Next technical data of the auxiliary system is intake air stream is 70 liter per minute. Maximum you can build 8 bar. The working temperature minus 40 to 50 degrees. Power supply is 110 volt DC. Electric power is 79 watts. Filling time, there are one reservoir is there. It is having a small capacity, 25 liter capacity is there. It will fill 140 seconds from maximum 8 bar. Now the first topic, the air supply. This is feeding the air to brake system. Brake system is for working the brake system we need air. Now first is the main compressor and auxiliary compressor. Now we are moving to brake control. What here I explained, there are 4 brakes are there. The service brake, emergency brake based on the train load, and these are the basic functions of what our brake system will work. Whatever basic functions, service brake, emergency brake, swing brake, and parking brake. These are the brake buttons controlled by our brake control unit. This is a panel. What is available in the Trainset coaches? This is a middle panel. It is having all brake components in a single panel. We are integrated all the panels are assembled in the manifold. So if the components were scattered over the train, there are a lot of joints will come, lot of pipe connection will come, leakage is more. To avoid that, we are making a simple compact panel integrated with a manifold. Inside the manifold, single manifold is having a drill hole. All the components interconnected inside the panel. Outside we are connecting header is there. From the header we are connecting the main whatever line is going to the train. That means MR, BP, brake cylinder line, suspension line, parking brake line. These are the line we are connecting in the header bar. From the header bar is entering to the panel. From panel, all the components are assembled in the panel. It interconnected with the drilled manifold. Inside the manifold, drilled panel is there. Inside the drilled parts are there. From there, air is entering to all the components. Here, a last experiment is a BCU. BCU is nothing but brake control unit. It's controlling an individual bogie. The left side BCU1 is controlling the left side bogie. Right side BCU is controlling the right side bogie. Here is a system is having a bogie control feature, not a car control. Car control means you have single EP unit, it can control both the bogie. Here a system is having a feature of bogie control. We are using 2 separate BCU, and each BCU is controlling the individual bogie. Next, B01. This is a B01 panel where MRR directly entering into the panel is a cock. Isolation cock is there. Once isolation cock is isolated, the pressure will not charge. There is also having electrical feedback. It will indicate the TCMS if the cock is open or not. You can open the DDU. The brake screen is there. From there, a lot of subsystems are there. Cock, pressure level, fault like this. From there, you can able to see what are the cocks available in the each coach. What are the position, either open or closed. You can able to see in the DDU. The MR are branching to this panel, B01 panel. From there, it's connecting to other subcomponents. Now, as earlier explained, this is the parking brake magnet valve and the isolation cock and the pressure switch. These are the 3 components for parking brake function. Next, air suspension. For air suspension, we are having an isolation cock. And filter and overflow always there. Normally, pressure starts filling 0 to 10 bar. First, the other main system, our auxiliary system, AR, will charge. The air suspension will charge only of 7.5 bar. The first priority is air brake system will work. For that, we will fill all the reservoir, that AR reservoir available at 75 liter, the individual coach. It will fill all the reservoirs in each coach. After that, air suspension also we are having one single reservoir. It's a capacity of 75 liter. It will start filling 7.5 bar. The overflow wall is available. It will start filling after 7.5 bar. Next, there is in the panel there are test points are there. During maintenance or troubleshooting, you can insert the gauge in the test point. You can able to see the pressure. What is the pressure in the available the MR line? What is the pressure available in the parking brake line? What is pressure available in the air suspension line? Individual line. Yeah.
Sir, it means air supply for air suspension is 7.5 bar.
Yeah, after 7.5 only it will charge. Air suspension system will charge after 7.5 only.
Sir, actually, the bellows cannot be charged from the starting point. जब स्टार्टिंग से चार्ज नहीं होगा सर, वो जब 7.8 के बाद ही बेलोस चार्ज हो जाएगा. इसके लिए हम लोग ने एक ओवरफॉल डाला है उधर.
नहीं सर, मैं ये जानना चाहता हूँ कि सर, हेलो.
हाँ सर बोलिए. हाँ सर बोलिए.
सर मैं ये जानना चाहता हूँ कि जो एयर सस्पेंशन के लिए जो एयर सप्लाई है वो
हाँ सर.
हमारा क्या 7.5 तक जाता है क्या लेवलिंग वाल तक?
नहीं सर, एक्चुअली क्या होता है जब गाड़ी बिल्कुल डेड है.
जी.
हेलो सर, गाड़ी बिल्कुल डेड है, वो टाइम क्या होता है सर, 0 से प्रेशर स्टार्ट हो गया तो आपका फिलिंग टाइम ज्यादा टाइम लगेगा. इसके लिए वी आर अप टू 7.8 तक बेलो का चार्ज नहीं होगा. सिस्टम चार्ज हो जाएगा. ब्रेक एप्लीकेशन कैन बी पॉसिबल. आफ्टर 7.8 बेलो धीरे धीरे चार्ज होते रहेगा.
बेलो तो अपने रिक्वायरमेंट के हिसाब से, लोड के हिसाब से चार्ज होगा, बट जो
तो बिल्कुल लोड स्टार्टिंग पॉइंट. हाँ सर, स्टार्टिंग पॉइंट जो होता है आफ्टर 7.8 के बाद ही स्टार्ट होगा इनिशियली. सब कुछ आगे हम देखेंगे. ओके अरुण, स्टार्ट पड़ेगा. स्टार्ट पड़ेगा.
Yeah, next is the B07 panel. The yellow one is yellow one. B07 panel is having a 2 pressure switch. One is connected in the MR line, other one is connected in the BP line. This is a pressure switch controlling the traction cutout. It's an interlock where once the MR pressure less than 6 bar, traction will prohibited. Similarly, BP pressure less than 3.5 bar, it will give the indication to BP is low. It will prohibit the traction. For indication purpose, we are connecting 2 pressure switches. One is MR line, other one is the BP line. If pressure below 6 bar, the traction will not prohibited. If pressure more than 7 bar only, you can be able to move the train. Similarly, if BP less than 3.5, your traction is prohibited. You cannot move the train. That's indication purpose. The traction interlock. We are using MR and BP pressure switch. Also, test points are there in the both line, MR point and BP point. Bottom of the pressure switch, we are having a test point. You can put the gauges and you can able to see what is the pressure exactly available in the pipeline. Next panel B02 is a green one. It is having a 2 isolation cock. If you isolate the left one, that means it's isolating BCU1, this left side BCU. If you isolate the right side BCU, you can isolate the right side cock. 2 cocks are there with feedback, electrical feedback. Then this is
अरुण एक्शन बने रहे. अरुण एक्शन सर, ये जो कुछ अभी मेरा कोलिग बोला था, अरुण बोला था सर, गाड़ी में ईपी ब्रेक टच करने के लिए, ईपी ब्रेक आइसेट करने के लिए आप एक कॉर्ड को यूज कर सकते हैं. एंड ऑल दिस कॉर्ड्स आर इलेक्ट्रिकली कनेक्टेड. शायद आप एक कॉर्ड को कट कर दिया, ड्राइवर को मालूम हो जाएगा एक कॉर्ड कट है बोलते. इसके लिए इट हैज बीन इलेक्ट्रिकली कनेक्टेड. दैट कैन बी विजुअली सीन बाय एमएमआई, मैन मशीन इंटरफेस में ड्राइवर का सामने हुआ स्क्रीन में देख सकते हैं. ओके मारून, स्टार्ट पड़ेगा.
Yeah. The next one is a B02 panel. Topmost is having a distributor wall, STV. It's a very compact wall. It's not like bulky one. It's a compact wall. It is having a 3 port. One is a MR AR, actual reservoir port. Other one is a BP port. Next one is a output. That means pilot to the BC. During the towing mode operation, whenever the drop in the BP pressure, the STV wall will sense the droppage, sense the BP drop. It will allow AR to the BC line. The function of the STV wall. It is using for backup brake or towing brake. Next, we are having a BCU. This is the main service brake. Main service brake and the emergency brake is controlling through this EP unit. We call it as BCU, brake control unit. It is having a 2 solenoid valves. That means pilot operated magnet valves are there. One is supply coil, another one is release coil, and one more coil is there. That is the emergency brake valve. The emergency brake valve, it's operating at 110 volt DC. It is operating at 110 volt DC supply. The emergency magnet valve is always energized. whenever the emergency loop is triggered due to any other reason, either any service brake is failure or overspeed indication is there, or driver emergency push button is pressed, the trigger, this coil will get triggered. That means the coil supply will disconnect and will allow MR air to the brake cylinder. That means the MR air will go to the pilot to the load dependent valve. From there, it will give the relay valve. From there, it will go to the brake cylinder. The coils are there. Two coils are very compact caliper, very compact coils. It is working with 24 volt at very minimum watt. The power consumption of the coils are very less. I think around less than 6 watts power only is required to control this coil. The small coils are there. One is apply coil, another one release coil. Whenever service brake is given, once I want to apply the brake, the service, that means apply coil will energize. It will allow MR pressure to this coil and will go to the load dependent valve. From there, it will go pilot to relay valve. From relay, will get the BC pressure in the brake cylinder line. We also having a pressure sensor. Here in the BCU panel, we are having a pressure sensor. Always we are changing MR pressure, BP pressure, load pressure, then final one is the BC pressure. All the four are very important pressure. Without MR, you cannot control the brake system. Complete brake system is working MR pressure. The MR is must. Next BP pressure. BP pressure could be 5 kg. Next is a load pressure. Based on load only, I can able to give the force to the brake cylinder. If load pressure also is very important, and output is the brake cylinder. These are the input. MR, BP, and the load pressure. These are the input. Final output is the brake cylinder pressure. You want to stop the train, brake cylinder is must. Once without brake cylinder, you cannot stop the brake cylinder pressure to apply the brake. The train, once exhaust the brake cylinder through relay valve, the brake will release. These are small coils. Whatever I explained in the coils.
How much pressure? Excuse me, sir.
Yeah.
How much pressure will go to the brake cylinder in emergency condition, sir?
सर वही मैं बोला था, इट इज ना लोड कैलकुलेटेड. सर एमएनजी प्रेशर में क्या होता है, गाड़ी पे कितना लोड है, मान लीजिए बोगी का ऊपर पूरा आदमी बैठा है, उसके हिसाब से प्रेशर आएगा. नहीं, बिल्कुल नॉर्मल है, बिल्कुल कम जाएगा.
Maximum how much? Sir, maximum how much it will be?
So generally, what is the maximum BC pressure?
Sir, maximum BC pressure
in full load is 4.1, sir. Maximum in the full load condition, train is fully loaded. That means full load condition during emergency maximum is 4.1. The minimum pressure from 1.8 will start. Minimum pressure. Yeah, you understand, sir? Yeah, I can move to next slide. These are two coils. One is charging and venting coil, and the cord is there. Electronic cord is there. It will control these two coils. The sensor, the feedback. Once I am giving the command, based on the command, the coil will open and pressure will go to the pilot to the brake cylinder. Whatever pilot is going, it will sense through this sensor. Whatever demand is given is achieved means it will loop will close. The closed loop system. I am getting the demand from TCMS. TCMS will give command to our EBCU, electronic brake control unit. From there, it controlling the BCU coils, two coils and sensor. A sensor will indicate the feedback. I received the 70% demand. I generated the brake force. The same brake force will give again back to the board. That means system is closing. This is a closed loop system. It consists of EP component, two pre-control valve. One is venting and charging. That means charging and venting valve. Also, it was a external system. Now is the brake control. Whatever the screens are shown is the pneumatic part. Pneumatic part with coil is having sensor and isolation cocks are there. Now we are moving to electronic.
Sorry for coils are exchanged. I mean,
yeah, coils are extendable, but it is a 24 volt operating coil.
No, sir. If you wrongly connected, any detection point is there, sir?
Suppose wrongly connected. No, normally the coil, coil connector is having a ferrule with a ferrule number is there.
Arun, Arun, card வாங்களேன். कार्ड सर एक कार्ड का सर एक कार्ड में हर कार्ड में एक नोड होता है सर. नोड मतलब ईच एंड एवरी कार्ड इज हैविंग एन मार्कर एंड हर कनेक्टर में मार्कर है. WS7 WS6 W3 ऐसा कुछ मार्कर है. एंड आप गलत कार्ड डाल नहीं सकते बिकॉज उसमें पिंस है, स्लॉटेड पिंस जो कुछ मैच ही नहीं करेगा. उसका साइड में काला कलर का पिन है, वो मैच ही नहीं करेगा. बोलिए सर, बोलिए.
Not caught, sir. That charging and this one is a previous slide. Previous
slide. Sir, charging and venting wall. Charging means nothing है सर. EP brake में जो कुछ हम बोलते हैं सर, होल्डिंग है, एप्लीकेशन का चार्जिंग बोलते हैं, होल्डिंग का वेंट बोलते हैं. एंड उसका ऊपर मार्कर है, W9 and W10 बोल के मार्कर है.
Sir, if you wrongly interchanged that one, is there any device is there?
सर वी कैन गेट अ फॉल्ट कोड सर. कंटिन्यूस वेंट होते जाएगा. जब गलती से डाल दिया चार्जिंग का वेंटिंग में चार्ज में डाल दिया तो जब ब्रेक अप्लाई करने के टाइम हवा बाहर जाते रहेगा. इट विल गेट माल फंक्शनिंग. सो विल गेट अ फॉल्ट कोड.
Even though polarity changes also.
Definitely sir, definitely.
So polarity changes automatically. MCB will trip.
No, இதுக்கு MCB இல்ல இருக்குனா இதுக்கு. Charging and venting wall doesn't have an MCB. Only for emergency we have an MCB.
You supply MCB.
Okay man, start பண்ணு.
Okay. This coils is having a cable marker. We can, if we cannot, you exchange the fault will detected by our EBCU, electronic brake control unit. It will give to TCMS. From TCMS DCU, that means DDU, will display the particular coach is having a EP failure. From the EP failure, you can able to understand there is a problem in the particular coach, particular unit. Now we're moving to brake control electronic part. We are using two EBCU. EBCU 1 for bogie 1, EBCU 2 for bogie 2. Each having individual cost, and I'm going to explain what are the costs, what are the purpose. The first one is the power cord. Then LED cord, the individual application. One for that means EP application, WSP application, and digital input output. Individual cards performing individual operations. That is we are calling as LED board, local application device board. Then is a KSN. The Trainset coaches, the KSN is a advanced feature. That means Knorr safety network. We are interconnecting individual coach as well as two coaches. There are each coach having two bake coach. Through KSN, we are connecting two bake coach. Similarly, we are connecting the next coach. If this coach is completely failed, they switch over to next coach. You understand my point? There are two bake coach are there. So the bogie rack one is failed. That means rack 2 will take care and give the signal to the bogie 1 EBCU. That means the redundant purpose. Due to redundant purpose, switchover possibility is available in the system. If other system, if any system is failed, you want to isolate complete system. You cannot get the brake force on the particular coach. Here we are having the switchover facility. That KSN is Knorr safety network is there. Whatever failing has happened, that unit will isolate it. We will get from the other unit, either from the same coach or next adjacent coach. These are the LED board, the power board and LED board and KSN and CAD. CAD is a central engine board. It is having a project specific software. These are housing installed in the coach. The train, the compartment area, there is one electrical control cabinet is there. From there, we can able to find the two Beku, the rack 1 and rack 2. The Beku 1 for bogie 1, the Beku 2 for bogie 2. First one is the power board. We are getting 110 volt DC supply from the battery. From there, the power board is having a DC-DC converter. We convert 24 volt and 12 volt for connecting the sensors and actuators. Our EP coils will work 24 volt. Sensor is there. Sensor will work 12 volt. Speed sensor is a 12 volt will work. Otherwise, some MR, BP, BCA or pressure sensors are there. It will also work with 12 volt. Then dumper wall, that means dump wall is there for the WSP system. That is also will work for 24 volt. We are getting 110 volt DC supply from the battery. Our power cord DC-DC converter will convert the recognized voltage for a different voltage. For both will work 5 volt. Sensors will work 12 volt. Coil will work 24 volt. Based on the requirement power consumption, it will give the output to other cord. Next, this is a CAD cord. Yeah,
Sir,
tell me,
is there
sir.
is there any protection for that cord? High voltage
sir.
or some other?
No, sir. Whatever power supply is there, no, they for connecting this power supply through contactor only. We are using the MCB. If any such a short circuit happens, this or the MCB will trip. You understand?
Okay, okay, sir.
Okay. Next, the CAD is there. CAD is the Central Intelligence Board. It is having a project specified software. Whatever logic to be worked in this brake system, the software is written in the code format, and we are uploading the software in the CAD card. The CAD is a Central Intelligent Board which contains project-specific software and control the North safety network. It is also controlling the North safety network. It is having a dual CAN bus. RS480 is the CAN communication bus. Also, we are having a Ethernet port is there. Ethernet port also there, and the RS485 is a communication to the TCMS. Our TCS from TCMS we are communicating through this RS485. Dual CAN RS485 is available. Also is having a North safety network. I told you earlier the individual unit from CAN 1 to bogie 2 will go. Similarly, CAN 2 to other coach. Next coach CAN 2 will go. We are communicating. The two coaches we are calling as a basic unit. Why means if the particular coach is having a problem, both the Bekus are failed. Then what I will do, next coach, the nearest coach and adjacent coach will give the EP supply to whatever problem is available in the coach. For that, we are using the North safety network. It's a communication gateway in the evaluation system. Is a communication gateway between the coaches. Through this card, we are communicating and distributing the brake force from next coach to other coach. Next is a pressure control board. This is a board, is a slave board. Master is this one. The CAD and the KSN is the master. Remaining all LED board, LED 06, LED 01, and WSP LED 05. These are the slave board. It will perform the individual function. This is the master. CAD and KSN is the master. Remaining all cards are slave board. They will perform individual operation. The LED 06 will perform the EP apply and release function. Right, from CAD through KSN, it will get the command, apply and release command through the KSN, CAD through KSN, this card. Then this card will directly connected to the BCU available in the underframe. The EP unit is there. From the BCU, it will activate the apply coil will activate or release coil. Whenever I want to apply the brake, it will activate the apply coil. I want to release the brake, it will activate the release coil. Also, we are reading the pressure, the food sensor, analog sensor, as well as speed sensor input. We are reading through this card. Next one is a digital I/O board. We are getting digital input from the train line. I want to know whether a master controller in driving position or braking position or posting. I want to know. I have to know. Brake system want to know the master controller is what position. That digital input we are getting from the train line. Driving zone or braking zone or posting zone. Similarly, there are two mode operation is there. One is a normal key on mode, another one is the audio mode. Normal, there is no communication failure in the train line. The train will work on normal mode. If there is any communication failure, they will switch over to audio mode. That means the resumed drive mode. The resumed drive mode purely through train line cable. On mode is through communication. These are the two major modes available in the Trainset coaches. Normal mode and audio mode. Normal mode, system is healthy, communication is also healthy. The signals will transfer in the communication mode. the communication, that means through data. In the RDM mode, that means there is a communication loss due to some failure. The communication is lost. They will switch over to RDM mode. All the train lines travel through the train line. That means analog signal will travel. This analog signal will travel. We are getting this input from the train. We are also giving the output, brake applied or released. We are indicating that how much load available in the coach. There are the output, various output, brake applied, release, and that relays some small major event, minor event. Similarly, there are 8 relays are there. We are giving output to the TCMS. Next, LED05, the wheel slide WSP cord. You know very well, most of you people are working in the LHB. There we are using LHB WSP system, same system, but we are using the different name. The LED05 cord. We are reading the 4 speed sensor input. Each axle having a 1 speed sensor. We are reading 4 speed sensor input. Also having a pressure sensor. BC sensor is there. The WSP will work whenever braking is there. So no braking is there, it will not work. Also, no use in the working that without air in the brake cylinder. WSP system will work. The air available in the BC pressure and whenever braking, that time only WSP system works. We are getting the 4 speed sensor input and 4 analog sensor input. Also, we are connecting the 4 dump walls. Dump walls is an actuator. Apply and release the brake simultaneously to release the lock. WSP is nothing but what? Some of the wheel is sliding or locking. To release the sliding or locking, I am continuously applying the brake force and releasing the brake force. This is for that person is doing this LED05 cord, WSP system cord.
So, excuse me, sir.
Yeah.
Sir, sorry, this WSP cord will not predict the wheel slip. It will comes in force.
No, yeah, correct. Your point is correct. Only wheel sliding. It's not wheel.
Sir, exactly right. It is not in the slip.
Pardon, sir?
Sliding, not the slip.
It's a wheel slide control. It's not slip control. It's a sliding control.
Whatever it may be,
Yeah,
the action it will comes in force after that action, slide action. Sir?
So your point is not getting. What is your query, sir?
Sir, this WSP system will comes in force after the slide is happened, but it will not predict that slide will come. Then have to work like that. It will not predict.
It will not predict, sir. Definitely,
Sir, it will not predict. It will not predict, sir.
Then first slip, sir. Then first time sliding, it will not be avoided.
Yes, exactly correct.
At first time sliding, at that time wheel may get damage. How we can arrest that one, sir?
Sir, actually, the electrical TCM, they're having some other features. Slip control, something is there in the system. Wheel slip control.
Arun, I explain. Sir, actually, sir, जब पहली बार slide detect हो रहे, what will happen, sir? There will be a speed difference. Okay, sir. So,
pardon, sir?
Once we get a speed difference on particular bogie, my dump wall will get activated.
Yes, sir. Yes, sir. That after experience difference of speed, then only it will act.
Yes, sir. Yes, sir. Sir, Arun, I can explain panama.
Sir, that's why I'm asking. The first time wheel sliding, first instance, the slide cannot be avoided.
Yeah, correct, sir. First time slide avoided. Once it's detected, then only I can protect sliding.
At that moment, that problem will not be avoided, no, sir. Wheel slide होने से जो problem उसको avoid नहीं कर सकते.
Yes, sir. But in the motor bogies, they're having some slip control is there, sir. They're having some feature of slip control wheel in the motor bogies, non-electric and without the motor bogies. The motor bogies, there are some logic of wheel slip control.
Whether it is slip or slide, it will not be predicted. It will only after the incident.
Yeah.
Then how will wheel slide or wheel slip?
No, I have to check, sir. I will get back if I once I will check with my design team and confirm.
Sir, WSP system allows a skidding and prevent from sliding. So it will allow a skidding and it will prevent sliding. Sliding is the process after a skidding.
सर जो एक्शन होता स्किड का उसका जो रिपरकशन तो अवॉइड नहीं का होता ना सर, स्किड होने से तो ट्रेड पोर्शन में प्रॉब्लम आ जाएगा। एंटी स्किड डिवाइस है, इट इज एंटी स्किड डिवाइस है अपने पास WSP में।
Sir, actually that name is not correct. Actually it should be anti-slide, not a skid, not valve, not a skid valve.
Sometimes you are telling anti-skid, sometimes you are anti-slip. Even though, sir, even though it is skid or slide, even though it is skid or slide, effect will be on wheel tread. So that problem will not be avoided in first instance.
Sir, can I explain, sir? Actually, two stages are there. One we call as a slip. During that powering, wheel is rotating in the same place. That we call as a slip. During
Exactly.
braking, if it is slides, that means it is what to call it? It is in a way it is sliding. Sliding only controlled by brake system, not slip.
I'm
Hello,
asking about sliding, sir. I'm asking sliding only.
Okay,
After
sir.
sliding happens only that this speed variation will come.
Yes, sir. Yes, sir. Sir, exactly right, sir. Your point is right. This will be clarified with our design team. Then I'll let you know, sir. Can we go forward, sir?
Sir, actually क्या है ना कि जैसे स्कीडिंग के टाइम में व्हील मूवमेंट होता है, लेकिन जब स्लाइडिंग जोन में चला जाता है वहां पे व्हील का मूवमेंट रुक जाता है, इसीलिए व्हील को प्रॉब्लम स्लाइडिंग से होता है, न कि स्कीडिंग से।
सर
बिल्कुल सही है। स्लाइडिंग में होते हैं, इसके लिए मैं बोला था जब स्लाइड होने के टाइम क्या होता है सर, जब स्लाइड होने के पहले स्लाइड कब होते हैं, व्हेन द स्पीड हैज गॉन टू 0, जब स्लाइड का डिफरेंस आ जाता है ना सर, वही टाइम अपना टप पोल काम करने के लिए चालू हो जाता है। हेलो
सर,
तो WSP सिस्टम आई थिंक allows skidding and prevents sliding.
Sir, actually, slip जो कुछ होता है, it is controlled by traction system. If the traction gives any feedback, then we will apply the brake. That we call as the indirect brake. And during the time of sliding, when braking हो रहे, braking का time, गाड़ी का speed difference आ जा रहे, jump ball will get activated, sir.
Sir, that's the thing. LHB same procedure is there, sir.
Yes, sir. Yes, sir. Same procedure, sir. That's why I told we'll get back the query, sir. That question will take up. We'll get back to you, sir, for that question.
Okay, sir. Okay, sir. Thank you.
Okay. Arun, please forward.
One minute. Yeah, this is a structure of how the WSP system is connected. The axle, each axle having a speed sensor. We are giving input to the WSP unit. Each axle, one sensor is there on two, and axle 1, axle 2, axle 3, axle 4. Similarly, each axle in the BC line connected to the dump wall. The dump wall is connected. The same is giving feedback. The BC sensor is there. It will indicate the BC pressure available or not. It will indicate the 2 units, that LED05 card. Then on each axle, we are having a pole wheel. That means phonic wheel connected to the speed sensor. If based on the rotation, it will change the speed signal. It will give the input to the extra unit. Once a wheel slide is directed, if any one of the wheel is sliding, there means there must be a speed difference is there compared to other wheels. Now there are 4 wheels are there. We are taking as a reference velocity 1, velocity 2, velocity 3, and velocity 4. If any one of the wheel is sliding or locked, that means it is not moving freely. It understood the sliding is directed by the system. That particular dump wall will actuate it through this cord and to try to release the locking or sliding. If I am taking 4 velocities, which one the highest velocity we are taking as a reference, and compared to individual axle velocities, if any one of the velocity is low, its system is detecting that some algorithms written in the software. If any one of the velocity is low compared to reference velocity, the system will sensing there is a lock on the wheel or sliding on the wheel. It will activate the dump wall and release the lock or slide of the wheel. This is how the WSC system is working. Now there is a schematic line from the brake cylinder line entering in the dump wall. From dump wall, the sensors
Sir,
are
here the
connected.
reference speed is the maximum speed of the axle.
Yeah, maximum. What is your question?
Sir, is the reference speed is the maximum speed of the axle in the particular coach?
Yeah, correct.
Particular
Reference
coach
speed we
or
are taking. No particular coach only. Actually, what is happening? Your point is correct. Here, bogie control. We are having a two-channel speed sensor. Normally, LHB and other we are using a single-channel speed sensor. We are using a two-channel speed sensor. The individual bogie speed we are giving to next bogie also. Our EBCU2. From now, I am giving one example. The bogie one is controlling through EBCU1. The axial one speed I am giving to bogie one, EBCU and also EBCU2. That means the two channel, one channel going to bogie one, Beku one, another channel also going to bogie two, Beku two. We are all four. That means all four speed sensors are they're taking as a reference, not in the particular bogie. You understand, sir?
Sir, one question, sir. Actually, sir, GPS system is also installed in Train 18, sir. I think some other purpose. So why we can't take our reference speed from GPS system, sir?
No, the reason is each system is having their own speed. For example, traction is also having a speedometer, tachometer. For brake side, we are having a speed sensors. So each system is controlling their own speed, and this is communicated through TCMS, Train Control Management System. Because we need our own speed, because each are calculating in different mode. GPS is calculating in different way of speed. They are also calculating speed, but the method of calculating is different. For us also it is different.
Sir, actually the reference speed should be that speed that train
Yes,
is moving with that speed.
Sir, absolutely right. The reference speed जो कुछ आप बोल रहे थे, that will be in a uniform. But the speed calculated on each system are different. Whereas traction side, वो tachometer से calculate करते हैं. Brake side, we are measuring through speed sensor. That through always through ponic wheel. Ponic wheel के साथ से हम measure करते हैं इसका.
So even though you not record a speedometer in the driver desk, you are getting the speed from GPS. But you have to redundant system. That means you have to double calculate it. In the particular driving car, you are connected in the tacho generator. From there, you are connecting the speedometer. But individual coach is having a GPS system. GPS display is there. It displaying the station where that station is locating. Forward, they are using the GPS speed and the location. This is the purpose. Now the DC line is connected to dump wall. From the dump wall, is connected to BC sensor. I told you there are 4 inputs we are taking. 4 speed sensor input and 4 analog sensor. The same BC line we are connected. We are having a BC pressure sensor, and that line is connected to individual DC line. This is axle 1, axle 2, axle 3, axle 4. In this axle, this C02/4 is having a cylinder with service brake. C03/4 is a cylinder is integrated with parking brake. You see the spring symbol is shown. This is a parking brake cylinder integrated with parking brake. The BC pressure is connected both the cylinder. Similarly, another axle to connected dump wall and a sensor, and is connected to both the cylinders. Similarly, other bogie having a separate axle. Axle 3 and 4 is having a separate dump wall. Same is connected sensor and connected to the brake cylinder. Now is a complete bogie 1 and there is a complete bogie 2. It is having a 4 service brake cylinder, 2 with integrated to parking brake. Similarly, there is also bogie 2, 4 service cylinder is there, 2 is diagonally opposite is having integrated with parking brake. Next one is a
actually, excuse me, sir.
Yeah.
One name of that dump valve is anti-skid valve. it is named that anti-skid valve. Is it correct? Actually, dump valve is, I think, it allows skidding.
Yeah, there is a name where actually the dump wall is where actually local language we are telling dump wall. Some of the anti-skid wall, some of the WSP wall. I will clarify, sir. I will actually is anti-skidding or it's protecting the skidding. We want to verify, sir. I will verify. Next is a pressure sensor. The speed sensor is working on the Hall effect, where there are two wires. There one we are giving the supply. The supply from the cord will come 12 volt supply. Next signal is the signal based on the speed. From 2 3 magnetic flux will created. From flux we are taking as a current. That current will give to the we are converted as the speed. Our EBCU will convert the current to the speed. The two wire, two channel speed sensor we are using. The gap should be the phonic wheel and speed sensor rate should be 0.4 to 1.4. Now we completed 3 parts: air supply and brake control and WSP. Now we are moving to other additional.
Sir, could you explain in detail how that speed will be calculated from a speed sensor and where that frequency is generated?
Yeah. This is a axial box cover. We are connected a speed sensor. The same is connecting to our WSP unit. That means our cord. This is a cord. This cord we give the two channel. That means what two wires are there. One is a supply, other one is a signal. We are giving a constant 12 volt as a supply to the cord. Now from the cord to the cable. There two wires are there. We are giving one supply, constant supply 12 volt. We are giving. It's giving to this coil. The coil will work based on all effects. That means the flux difference available due to rotation. The flux will difference. The electromagnetic flux difference will create. That difference is here a small cord is there. It will convert as a current. I am giving 12 volt supply. That 12 volt supply will go to this flux. That means the edge. Here there is a magnetic flux difference will create based on the rotation of the pole wheel. Then it will convert it as a current. The current will go to the our cord. Our call calculate convert to current to speed.
Sir, is it voltage based or current based one, sir? Speed sensor?
Current based one. Current based one.
Current based only.
Yeah. The next one is the additional signaling equipment. There is a ons, high tones, low tones on available in the DTC car. Each end of the DTC car is having a on, high tone, low tone on, sir. It's a electrically operated on, fitted magnet coils are fitted. Two magnet coils are there. It will trigger based on the pulse. That means when the driver does, two push buttons are there. It will apply the 110 volt supply. It will work on 110 volt supply. If you press the high tone on, the high tone magnet coil will energize. It will allow the air. It will allow air to the this on, and it will blow the air. Similarly, P02/2 is a low tone coil. It will also trigger, and it will allow the air to P04 typhoon, and it will work. The tone frequency is high tone is 660 Hz, low tone is 370 Hz. The compressed air will pass once the coil is energized. When will energize the coil? When driver is applying the on button, the coil will get energized. It will allow MR to the diaphragm through this magnet coil. Whenever it is pressing low tone coil will trigger and it will open. That means energize and it will open the part. It will allow MR to the low tone typhoon. Also, we are having a ball cup. If your arm is malfunctioning or continuously blowing, you can close through this block. Then the gauges are available. Dual gauges available in the driver desk. You can able to see the pressure in the analog format. The digital format also you can able to see through DDU. Also, which is having analog feature. Analog gauges are there. The dual gauge, which is having MR and AR. MR is the main reservoir pressure. Complete train line is available. Same sampled in the DTC core, and AR auxiliary reservoir also we are taken from this coach, and we are displaying what is available in the AR and the particular coach. AR of particular coach, MR of complete train line. Here the BP gauge is there, and BC gauge. There are 3 gauges are there. Dual gauge, MR and AR, one BP gauge and one BC gauge. Now we are moving to bogie equipment. The system, this is an electronic system. It will triggering this EP panel. From EP panel is going to caliper and applying the brake. This is a actuating component, brake actuating component. The caliper and disc. Now the CCMS command giving to this electronic unit controlling this panel. From this panel, we are giving air or releasing the air to the caliper. Caliper will apply the brake and release. This is the structure of how the components getting actuated from where the supplies are coming. The caliper, what I told is a purely service brake caliper. Service brake integrated with parking brake. Here also service brake. Diagonally opposite is having service, and diagonally opposite is parking, integrated with parking brake. Each bogie is having 100% service brake, 50% is parking brake. Now this is a pictorial view of compact caliper. This is a bracket is mounted on the bogie frame directly. The 4 bolts are directly mounted through bogie frame. This is a slack adjuster. You can, this is a slack adjusting screw. You can adjust and gap. We can create the gap between the wheel disc and the pad holder. This is a wheel integrated. The wheel integrated with the disc, wheel disc. This is a structure of wheel pressed in the disc. This is a brake pad holder. You can adjust this screw. You can enlarge or compress the brake pad using this adjust screw. This is a brake pad holder key. You want to change the brake pad. There is a key is there. You can pull out the key and insert the brake pad and lock it. This is a spring applied brake. The parking brake release. You can, in case of the malfunction or parking brake is not releasing, you can pull the spring and you can pull the spring. Parking brake will release. Manual pulling. This is a bracket and slack adjuster. Manual pulling. This is a brake pad holder, and the key is there for inserting and removing the brake pad. This is a mounting frame. The mounting here is the mounting. The mounting in the bogie frame. Using the slack adjuster screw, you can adjust the gap between wheel disc and the brake pad. Once your gap should maintain 2 to 4 mm normal release condition, the gap should be the wheel disc and the brake pad should be 2 to 4 mm.
Sir, this brake actuator is a self-aligned or a fixed one?
So self-aligned, auto slacker is there. You can apply the auto slacker, the self-aligned only.
Sir, could you please show us the cross-sectional view of brake cylinder? How 2 chambers are aligned in that brake cylinder?
I cannot share now, sir. If you want, I have small schematic later on. I will share, sir. I will give my number. You call me, sir. I will check for that one. After finishing this meeting, I will give the number.
Okay, sir.
This is a parking brake control. Parking brake. The MR is branched. MR is branched through this pop, and it will entering the. This is schematic. How the air branches to various lines. The MR is a through train line is connected. From there is a parking brake is connected. Similarly, air suspension also is a schematic diagram. Air suspension also connected. The impulse valve and that double check valve is there. This pressure switch. This red one is the parking brake line. Is diagonally opposite side connected. The MR loss. If loss of MR, automatically parking brake will apply. If you want to release the parking brake, again you want to fill the air. Next is air suspension. Air suspension here I explained. From MR is branched to the air suspension line, the isolating cock, filter and overflow valve. It's set at 7.5 bar. After 7.5, it starts filling. This is a reservoir. The reservoir skid is there. One is a 75 liter capacity. It will store. From there, it will come to the bellow. This is the individual bellow. These are two bellows. Or the opposite side also two bellows. This is a leveling wall and duplex check wall is connected. Based on the load, is a leveling wall give the air to bellows charge. This is air suspension. This is a complete schematic of train set coaches. This is a complete schematic. This is a single unit with air supply. This is a reservoir skid. Two reservoirs, the single plate. That means the single skid. Single skid is having a two reservoir. This is a complete brake panel. These all are having complete brake panel. I earlier told there are 5 boxes. No, the complete brake panel available in the single skid. This is why the compressor is having single unit. Reservoir is also single unit, and complete brake panel also having a single skid. Then this air suspension also having a single skid. So totally in the underframe of the train, you can find 4 skids. One is the complete middle skid, reservoir skid, and both end skids. The DTC and DTC, you are having a compressor, and TC, you are having a auxiliary compressor. This is a DTC schematic. DTC is having a compressor and also cab equipment. These are arms and the driver brake wall available in the cab. Apart from this, TC is having auxiliary compressor. The function of leveling wall. The bellows are mounted on the bogies of car. The car bodies are air bellows. There are 3 modes of operation. The normal mode. That means normal mode. Normal mode. Either you see the leveling wall connected to the bellow. This is a leveling wall connected to the bellow. Also insulation river is there. The handle of leveling wall in the 0 degree. If you are loading, more passengers are loading on the particular coach, it will lift and it will fill the more air. The bellow will charge and will give them more pressure. Then people are unloading. That means platform came, one station came, some 50% of people are getting unload. Air will exhaust through leveling wall. There are 3 modes. The normal mode, no passengers are available. Some point of air will charge in the bellow. If passengers are loading, more number of passengers loading, if bellow will charge. More passengers are getting unload, bellow will discharge a pressure through this leveling wall. This is for balancing the bellows based on the load. It air spring will charge and discharge. Yes, and now this session is completed. We have covered air supply, brake control, WSP, signaling, and WSP, and air suspension system. This is a brake system we are installing at train sheet coaches. Now you can ask any queries.
Sir, could you please explain us the one valve you told about, that load dependent valve which are used in braking? How that functions?
Yeah, one. So now I am explaining through schematic how the load is coming to the vehicle. You zoom it out one minute. This is a bogie 1, sir. Sir, this is a bogie 1. We are having 2 bellows. From below is the load. It is whatever pressure available in the bellows is having an exact load of the coach. That means the exact load on the particular bogie. We are averaging the both bellow pressure and giving to load dependent valve. This is a UP unit. We are having 2 coils, on apply coil and release coil. This is a load dependent valve. You see the pressure coming from the load dependent valve. The pressure coming from the bellow. This is a mean pressure valve, averaging the both bellows and giving output single pressure coming to this piston valve. This is a piston valve available. From there you are coming. This is a T. T is a load pressure. You see, this is a both bellows are there based on load averaging. That means mean pressure is averaging. One single pressure will come to this point. Here one mean pressure wall is that a piston wall is there. In case if you are isolated, it will directly, the 6 bar pressure available, PRV is a 6 bar, it is set at a 6 bar, it will give constant pressure. If you not isolated, whatever exact pressure available, that pressure comes to here and it will give to here. This is a load pressure coming to load dependent valve. And whatever load, how much load is coming, that much pilot pressure only will go to the relay valve. You see this. The bellow pressure coming to here and it connecting one piston valve is there. There are piston valve, 2 ports are there. In case of this bellow is burst or something leakage is there, if you isolate, the constant MR, that means we are regulated at 6 bar and giving to this load pressure. If is LC condition, whatever exact load is coming from the bogie, that is connected to the piston valve and giving to this load dependent valve. From here, how much load dependent pressure is coming, that is the pilot to this valve. It will allow, if I am giving 2 bar load pressure, I may allow only 2 bar pressure to the relay valve. From there, it will go into BC cylinder. Are you understand, sir?
Sir, if bellow burst, then how that pressure will be calculated?
Yeah, we are constantly giving 6 bar. If you isolate this below, we are having one regulator. PRV is there that is set at a 6 bar. We are giving constant pressure to the load valve. That means, you understand, no, sir? If you isolate this below, I will not get the below pressure from the bogie. What I am doing, there one more port is there that is directly connected to the AR, actual reservoir pressure. That time I am giving constant pressure to this load valve. Or you understand, sir?
Okay. Understand.
Okay. Sir, any queries you can ask now.
Hello.
Yeah, tell me.
Hello. Hello. Please explain, sir,
Yeah,
once
tell me.
more.
What, sir?
Please explain once more, please.
One more time.
The piping diagram which you have explained just here, just now. Please explain once more.
Yeah. Yes, I. 10 முறை பண்றது சொன்னாலும் புரியாது. Sir, this is a below, sir. From below, we are calculating the load pressure from the air spring. Normally, based on the load, air spring will fill up. If a train is full load, air spring will completely charge and give the maximum pressure from whatever load. Based on the load, it will give the maximum pressure. I am taking 2 below pressure and averaging. If I am giving one example, the one below is having a pressure of 4.5, other below is having a 5. That means 9.5 by 9.5 bar. That means mean pressure is 4.7 something. We are giving to load to the particular bogie. From that load will come to this load dependent valve as a pilot. That time, that much pilot, that much MR pressure I am giving to relay valve as a pilot. Based on load, I am allowing pilot pressure to relay valve. If load is less, around the 2 bar is their load in the coach, I am allowing 2 bar pressure only the pilot to the relay valve. That means that much 2 bar pressure only will go to the brake cylinder. If train is fully loaded, that means the maximum pressure, that means the train is fully loaded, more than 5 bar load pressure is coming, the pressure will come to 5 bar. This is the logic.
Actually, I want to know the exactly which component are involved in delivering the pressure only. The main thing is that because there is some speed restriction, communication problem. Please explain the actual components which are directly involved in transmitting the pressure from bellows to the control or the controlling devices till supply. I want only this.
The actual components we are not taking a screenshot, sir, even though
I want only
Arun, one second. Sir, leveling wall से charge होते हैं. जब bogie का load आते हैं bellows में, जब bellows से leveling wall is the first component. After that, duplex check wall. After that, we are using pressure governor and pressure test point to measure what is the pressure is recorded in particular bogie. उसके बाद ये direct piston valve also, because due to pipeline we are using piston valve so quickly.
सर आवाज की प्रॉब्लम आ रही है।
आवाज नहीं आ रही सर आपकी।
सर क्लियर है सर? हेलो
अगर मास्क हो तो मास्क निकाल दो सब, आवाज तो क्लियर नहीं आ रहा है।
ओके सॉरी मास्क निकाल देते सर, एक सेकंड सर, मास्क निकाल देते सर। एक्चुअली क्या हुआ था, गाड़ी का जो कुछ लोड था पहले बेलो में चले जाते, बेलो से अपना लेवलिंग वॉल वाज इन्वॉल्व, लेवलिंग वॉल द फर्स्ट कंपोनेंट व्हिच इज इन्वॉल्व फॉर दिस लोड कैलकुलेशन। उसके बाद यूप्लेट चेक वॉल, इफ देयर एनी डेविएशन द बेलो बस्ट हो गया तो वो टाइम वो इन्वॉल्व होता है। उसके बाद प्रेशर गवर्नर सेंस करने के लिए एट दिस पॉइंट टू मेजर बेलो एक बेलो में कितना प्रेशर आ रहा है वो मेजर करने के लिए उधर से ये जा रहे हैं पिस्टन वॉल, बिकॉज ड्यू टू पाइपलाइन मेरे पास जल्दी आने चाहिए था। एक पर्टिकुलर बोगी में कितना लोड है वो मेरे के पास जल्दी आने चाहिए था, इसके लिए पिस्टन वॉल यूज कर रहा था। उधर से ये सीधा जा रहे पीसीयू के अंदर, दैट मींस ईपीयू के अंदर जा रहे थे। सर अभी क्लियर है? सर अभी क्लियर है?
They are unable to follow you.
Okay, sir. I'll ask my colleague to send my number also. I can explain you once after the training session. I explain कर लेता हूँ sir. You can send me the queries. Whatever the queries, you can mail me. I'll explain to you.
Sir, we can wind up this class or any queries is there?
Sir, one more question. Sir, can you explain the effect of atmospheric pressure on the efficiency of air compressor?
Yeah, what is your query, sir? Repeat once again.
Can you explain the effect of atmospheric pressure on the efficiency of compressor?
Yeah. So normally in the atmospheric pressure, the humidity level in the atmospheric pressure is more than 6.5, more than 65%. We are sucking that atmospheric pressure and giving to the piston chamber. The first the low pressure. That means the whatever atmosphere is having a very less pressure. Then we are entering into the piston. It will low pressure cylinder will press it, and that means it compresses more and give to some 4 bar pressure. From there it will go to intercooler. Intercooler again from the intercooler it will connect to high pressure. That means here the volume of pressure will compress more. That means high pressure. That means it can compress up to 12 bar. From there after 12 bar again I am giving to after cooler. The cooling panel after high pressure is more temperature. I think around more than 50 degree, 70 degree also will come sometime. The cooling fan will cool and it will give to low pressure and will give to air dryer. Air dryer only will reduce the moisture level and reduce the humidity level. There is an absorbent medium available in the air dryer tower. That means desiccant is available. It will reduce that humidity level less than 35%. That final delivery to the pneumatic line is less than 35%. Normal atmospheric air, more than 65% of humidity is there.
So, sir, have you any data of air delivery of compressor in respect to atmospheric pressure? Suppose here atmospheric pressure is 1.03 and in lake and oxygen on hill it is 0.62 up to 0.6. What would the effect of air delivery of compressor in respect to the atmospheric pressure?
No, I'm not getting the delivery. How to know what is the delivery of the air you are asking, sir?
Yes, suppose any compressor is delivering 45 liter per minute air.
Yeah, correct.
And which is required, which is enough to for our pneumatic suspension or airbag system. And now it is on suppose in Delhi, and now the train has arrived in Leh or suppose Srinagar, and there the atmospheric pressure is 0.8 or 0.7.
Okay, okay, okay.
What will the effect of air delivery or efficiency of compressor at that height? And
No,
higher
yes.
altitude. Yeah.
If even this compressor will work on is a proven compressor will working in Europe also. Europe is I think where service temperature range of the compressor is -10 to +50 degrees Celsius. Even it will work up to -10 as a very low. That means a low pressure. That means what a low temperature also it will work. Only delivery maybe delivery take. Now here 845 liter per minute means it will charge the complete train 25 minutes. If its temperature is very low, it will take extra to filling the air. That is a
सर
concept.
atmospheric pressure फर्क रहेगा तो if there is a difference in atmospheric pressure by intake filter for LP cylinder the duration time will take little bit more sir but time थोड़ा charging time थोड़ा ज़्यादा रहेगा and compressor will work little bit more for example मेरे पास 2 LP है 2 LP से मतलब सक करके वो प्रेशर को atmospheric pressure सक करके बिल्ड कर रहे ना सर वो थोड़ा टाइम ज़्यादा रहेगा
सर मैं यही जानना चाहता था कि इन रिस्पेक्ट टू हायर एल्टीट्यूड जो इस पे अगर मान लीजिए कि हमको प्रेशर की रिक्वायरमेंट जो है वो डिसाइड करनी हो किस कैपेसिटी का क्या है तो अगर मान लीजिए कि हम हाइट पे जा रहे हैं तो बेसिकली वहां पे एयर जो है वो रेयर होगी कंप्रेसर जो है वो हमको अगर एयर की डेंसिटी कम है उसको compress करेगा तो डेफिनेटली उसकी इफिशियंसी तो डाउन होगी उतनी डिलीवरी हमको नहीं मिल पाएगी
नहीं बिल्कुल बिल्कुल सही है सर उसका एफिशिएंसी थोड़ा कम होगा बट कब ऐसा
चार्ट है क्या
कंप्रेसर
जी
सॉरी सर सॉरी सॉरी सर बोलिए बोलिए
उसका कोई चार्ट जो इन रिस्पेक्ट टू
नहीं नहीं चार्ट आप चार्ट मांग रहे हैं ओके सर चार्ट विल ट्राई टू गिव यू सर विल चार्ट द चार्ट हम दे देंगे सर ऐसा कोई प्रॉब्लम नहीं है चार्ट दे देंगे सर सर आपका जो कुछ क्वेरीज है ऑल द क्वेरीज विल बी आंसर्ड आई विल आस्क माय कोलीग टू शेयर माय नंबर आल्सो माय मेल आईडी आल्सो इट विल बी आंसर्ड राइट नाउ आई एम इन अदर वर्क दैट्स व्हाई अनएबल टू स्पीक राइट नाउ कोई डिस्टर्बेंस आ रहा है आपका क्वेरी जो कुछ है आई हैव गिवन माय मिस्टर शंकर जा सर हैविंग माय नंबर you can take my number I can share my mail id also you can ask me whenever I want and I'll ask my colleague also Mr. Arun Kumar he also will share my mail id and number sir okay sir
okay sir thank you
Arun number set கொடுத்துருமா
Yes, sir. Any other queries, sir?
Okay, sir. Thank you.
Yeah, thank you. Thank you.
Sir, thank you to all. All the queries will be answered. I'll share my number to Mr. Shankarji and mail ID also, sir. Okay, sir?
Okay, thank you.
Thank you. Thank you.
ஹலோ மெயில் நான் கொடுத்துருக்கேன் வந்து நம்ம ஆன்சர் பண்ணிக்கலாம் ஒன்றும் பிரச்சனை இல்லை சரியா என்ன சரி பேச முடியல சரி
சொல்லுங்க. ஒண்ணும் இல்லப்பா, விடுங்க. அவன் என்ன இரு. போட்டிருக்கேன்னு சொல்லுங்க. இல்ல அவன் வைண்ட் அப் பண்ணிக்கலாமான்னு கேட்க சொல்லுவாங்க. அவங்களுக்கு கேட்க சரி அங்க கேட்க சொல்லுவாங்க சென்டர். ஓகே.
Thank you. Thanks a lot.
தேங்க்ஸ்.
Arun, can you share the PPT in the group?
Yeah, I will share it.
Right. Thank you.